We are the group that are doing LitterDrones.
My name is Brandon.
My name is Uttam.
My name is Charlie.
My name is Israel.
And the cameraman's name is Maru.
For our project of taking math further, we decided to create and investigate LitterDrones. These drones can reach litter in which we are unable to access. Doing the math for the LitterDrones, we hope to take the drones further to anything. This idea came about from seeing the huge amount of litter in our city.
The maths that we are doing is trigonometry, calculating and coding drones. By using trigonometry triads, we can find the angle of elevation and depression to pick up the unwanted litter.
In the mass of the drones, we can figure out how much it can lift, thereby figuring out if we can lift the litter or not. By coding the drones, this will allow us to pick up inaccessible litter anywhere, even places humans can't reach.
Trigonometry and Pythagoras' theorem are math concepts that allow us to find the features of a triangle. For example, find this side here, also known as hypotenuse C, because it's the smallest, we can use this formula. C squared is A squared plus B squared.
Which is Pythagoras' theorem.
A squared would be the shortest side, 30 meters squared, 30. B squared would be the middle side, 150 squared. So C squared will equal 30 squared plus 150 squared, which equals 30 squared plus 150 squared are 23400 meters. But that's not C, obviously. That's not that long. So we need the square root of that to figure out C, because this is C squared. C equals square root 23400. 152 meters. Means this side 152 meters. To figure out the angle of elevation, we can use Toa. Because we know all three of them, we can use any one. I'm going to use Toa because I want Toa. So we start Toa with tan theta equals opposite over adjacent. And we substitute in the values. Tan theta equals opposite, which is opposite 150, adjacent 30. 150, 30. Now theta equals, now when you bring this over here and inverse it, tan inversed 150 over 30, which equals 78.6 degrees. With that, we know the angle of elevation, meaning we can drop the drone down and bring it up.
And walk with it. That's it, over it. Yeah.
To justify the mass of what the drone can pick up, we needed to weigh the drone in comparison to the types of litter that will enable it to lift. Therefore, a fair test had to be done by repeating 3 times of weighing the drone and also 3 different types of litter to find average weight. This force diagram shows the force applied and the force of gravity to allow the drone to lift.
Drones are the future of technology, using both physics of aerodynamics and trigonometry triads to alleviate problems of time management in relation to saving lives.
Thank you for listening to our project about LitterDrones.